Hello everyone, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, assuring the successful launch of voice over Wi-Fi devices and services, presented by Spirent. Our presenters today from Spirent Communications are Alan Way, Senior Manager, Methodology and Platforms, Rich McNally, Director, Service Experience Programs, and Rupert Lloyd, Senior Product Manager, Service Experience Solutions. At this time, I'd like to pass the presentation over to Alan.
Good morning, everybody, or good afternoon, wherever you are in the world. Thank you for attending this Spirent webinar. I'd like to start off today by talking about voice over Wi-Fi, why it's being adopted by the carriers, why in fact Wi-Fi is becoming carrier grade, why the carriers are moving towards Wi-Fi, some of the technology which is enabling it. We'll touch on some of the financial reasons, and also, very importantly, who's using it. So let's start off with why. Well, first of all, if we take a look at the carriers, there's only a finite amount of spectrum out there for the LTE people, and there really isn't enough. With the mobile access exploding, LTE spectrum is going to be insufficient. If we take a look at Wi-Fi, just in the 5 gigahertz spectrum alone, there's over 500 megahertz of available spectrum. This isn't even including the 2.4 gig spectrum. Also, very importantly, the cost per bit is very attractive. As far as the carriers are concerned, it's basically free spectrum. Another very important point of Wi-Fi is that it's going to help improve service. LTE doesn't really penetrate large buildings very well. For example, shopping malls. Distributed antenna systems can be used, but they're rather expensive to install and deploy. So Wi-Fi is ideal for large office buildings, shopping malls, etc. And again, as I said, it's relatively inexpensive to deploy. So how is the coverage for Wi-Fi? Well, it's becoming ubiquitous. As of the beginning of this year, there are nearly 50 million hotspots worldwide deployed. This is an 80% increase on the total that were deployed in 2013. By 2018, we expect the total to hit 350 million. Today, there's only one hotspot for every 140 people, but by 2018, there's going to be one hotspot for every 20 people on the planet. The US is also moving very, very rapidly. By late 2015, iPass is forecasting that there'll be 32 million hotspots alone in the United States. Now, this seems like an incredible number. How are we going to get there? Well, remember, last year, we began the year with only about 1 million hotspots. And one company alone, Comcast, pretty much single-handedly deployed an additional 8 million hotspots in the US. The other multiple service operators, such as Charter, Time Warner, Bright House, I don't think they're going to be left behind in this race to deploy Wi-Fi hotspots. With the recent merger, they've basically formed a company now which services over 23 million people. So I expect to see many, many more Wi-Fi hotspots deployed during the course of 2015. Now, 32 million is a large number, but most of the pundits out there agree that the number will fit somewhere between 20 million and 30 plus million by the end of the year. If we look at the number of hotspots by country, we can see that last year, at the end of the year, France was leading the pack with over 13 million hotspots deployed in their country. Why was France the leader? Well, most probably because the cost of LTE access for data in France was relatively high until quite recently. So there was a much bigger impetus to move towards Wi-Fi as quickly as possible. The US at the beginning of the year was well behind with only just over 1 million hotspots deployed, but due to that a massive effort by Comcast, we finished the year just short of 10 million hotspots. In third place, you can see the UK coming in at just over 6.5 million, and the rest of the countries following behind. I would strongly recommend, if you want to get more details on this, go to the iPass website, and you can actually view the world map on the number of hotspots being deployed and a lot of other very useful information. So let's take a look at some of the technology which is going to basically boost Wi-Fi into a whole new category of usage. That's basically making it carrier grade. One of the most important technologies which has been emerging over the last couple of years is 802.11ac. And this year we're beginning to see the deployment of Wave 2 products. For example, last year we saw the first Wave 2 products for the home user actually hit the marketplace in late August. Asus was one of the first companies to hit the market with a home consumer product, but this wasn't really targeted at enterprise usage. But just recently, literally within the last couple of weeks, we've seen announcements from Aruba and Ruckus announcing Wave 2 products for the enterprise space. These are much more sophisticated devices which can be deployed on a very large scale. 802.11ac Wave 2 will potentially bring us nearly 7 gigabits of throughput. We're going to be using much more advanced modulation techniques with 802.11ac, such as 256 QAM. We saw this deployed already in the Wave 1 products. But with Wave 2, we're going to deploy Wi-Fi in a completely new and exciting way, basically moving from a hub architecture to a switch architecture. Basically, the way Wi-Fi works today, first of all, we have to understand it's a half-duplex technology, but it operates very much like a hub. Everybody has to take their turn. But with 802.11ac Wave 2, we'll actually be able to support up to 4 people simultaneously using 4 spatial streams. And much better spectral efficiency will be realized. By the end of the year, we may even see 8x8 systems where up to 8 individual users could be supported simultaneously on the same frequency, again improving the spectral efficiency. We'll also see other technologies being deployed as well, such as improved beamforming. Although I don't think this is quite so exciting for the carriers, this could actually be very useful to the home user. Beamforming allows the access point to basically steer the beam to a specific point within the house or the building, improving the signal strength. But for larger users or high-density applications, such as a university auditorium, the 4x4 MU-MIMO support is going to be much more attractive. So the MU-MIMO is going to be very attractive in terms of usage in high-density environments, such as hospitals, universities, even high schools. The AC technology is already taking a firm grip in the market. 30% of controller-based access points shipped in Q4 of 2014 were already 802.11ac. Now, the vast majority of these access points would have been Wave 1, but we expect Wave 2 to be taking a serious grip on the market by Q3 of this year. So let's take a look at how some of this technology works. First of all, let's take a look at single-user MIMO. Single-user MIMO basically means single user, multiple in, multiple out. And this was available actually with 802.11n, the earlier generation of Wi-Fi. But basically, this is how it would work. With MIMO, we can actually use the same frequency on 2 radios to double the capacity of a given piece of spectrum. So basically, we transmit 2 different streams of data to the UE or to the device. Basically, we double the throughput for a given piece of spectrum. This is a very attractive technology. But everybody has to take their turn. First the phone, and then the tablet. Then back to the phone, and then back to the tablet. With MU-MIMO, we're going to be able to operate in a slightly different way. We're going to be able to increase the spectral efficiency one more time by making much better use of the spectrum by supporting up to 4 different devices simultaneously. And by the end of this year, with the rapid advancement of the technology, we may even see up to 8 users being supported simultaneously with the same RF spectrum. Basically, we have in this configuration 4 radios with 4 antennas transmitting 4 spatial streams. Each one of the spatial streams is using the same RF channel, but each one of those spatial streams is sending a different stream of data. So now we're acting much more like a switch than a hub. So this is basically how it's going to work. We're going to be able to support 4 different devices simultaneously. So instead of each device having to wait its turn effectively in a hub environment, we're now supporting all 4 in parallel. And as I said, by the end of the year, who knows, we may see devices hitting the market which can support up to 8 individual devices simultaneously. The technology for voice over Wi-Fi and handoff has actually been around for a few years. One of the biggest problems facing a mobile user is how to associate with an access point. You really don't want to be entering your username, password every time you want to hand off from an LTE environment to a Wi-Fi access point. This has to be achieved completely seamlessly. And the technology to facilitate this is called Passpoint, or Hotspot 2.0. This is based on the IEEE standard 802.11u, and you'll find many phones on the market already today support this technology. Basically, 802.11u is going to facilitate automatic network discovery, quality of service mapping. Don't forget, it's going to be very important that we have good quality of service over the air for the voice component of the call. Data can be a little bit more forgiving, but voice, well, that's real time. We need very good service. And last but not least, it's going to provide security authentication, typically using ePSIM, which is the Extensible Authentication Protocol. Basically, the credentials will be based on the existing SIM card within the mobile phone. This technology has been around actually since about 2011, and I think the actual first deployment of this technology was possibly by Boingo in Chicago Airport back in 2012, but at that time very few people were even aware that the technology existed. Today it's becoming much more widespread, and there are hundreds of thousands of access points throughout the United States and other parts of the world supporting Passpoint Hotspot 2.0, all based on 802.11u. So how does it work? Well, basically the access point is going to broadcast in its beacon that it does support, in fact, 802.11u. The cell phone then, or the UE, using the generic advertisement service protocol, can do an access network query protocol to the access point to determine what type of network we're dealing with, what type of authentication is available, and the roaming partners. For example, you may be able to support off one access point all of the common carriers such as AT&T, Verizon, Sprint. If you're in other parts of the world, possibly British Telecom, France Telecom, etc. Hopefully you'll find one of the roaming partners that you've subscribed to, and then your phone will hopefully completely seamlessly, unbeknownst to the user, authenticate with the access point, and you'll have a nice clean handoff for voice and for data. As I said, there are a number of phones on the market already supporting this technology. The new iPhone 6, the iPhone 5, 5S all support this technology, along with the newer Galaxy phones as well. Microsoft with their Lumia 640 also support this technology. And if you go into your configuration or settings menu on these phones, you'll be able to find areas where you can configure for this type of support. Of course, you have to subscribe to the service, and your carrier obviously has to be able to provide this type of Wi-Fi calling. Another important component, which again, actually I first saw at least 3 years ago, is the Access Network Discovery and Selection function, the ANDSF. This is being built into the Evolved Packet Core. The LTE Evolved Packet Core is a very complex environment involving a number of discrete components which together form the LTE network. You've got, for example, in there the multimedia management entity, which is going to keep track of your cell phone. This is going to talk to the Access Network Discovery and Selection function. And basically, when you come in range of a wireless access point, the ANDSF will suggest to your phone that you get off the LTE network and move on to the Wi-Fi network. So the ANDSF is going to provide a much more intelligent push, if you like, from the LTE network onto the Wi-Fi network, and of course also in the other direction. It'll also suggest when appropriate to move off the Wi-Fi network onto the LTE network. This brings another layer of intelligence, if you like, into the network, and it will only suggest this move if resources are available on the access point. So how is Wi-Fi being adopted by the consumers and the devices in the marketplace today? Well, Wi-Fi is already having a big impact. 93% of US data usage on tablets is via Wi-Fi versus only 7% for cellular. So tablets are already predominantly using Wi-Fi services. Surprisingly, smartphones also tip to Wi-Fi by a 57 to 43% margin. So 57% of data coming onto smartphones today is actually coming off Wi-Fi versus 43% of the data coming off the LTE or traditional 3G networks. By the way, I just read very recently that the vast majority of cell phones being purchased in China are now smartphones, although they are a little bit concerned in China because the uptake in cell phones has taken a dip. I say this a little bit tongue-in-cheek. The number of sales of smartphones and phones in general in China dipped by about 4.4% during Q4 because the Chinese market apparently is becoming saturated. They only shipped around 98 million phones. This is an absolutely incredible number of phones, and they regard this as a dip. Multiple service operators project a 10 times increase for hotspot deployments in 2015, and the Cisco report from 2014 forecasts that 64% of cellular traffic will be offloaded to Wi-Fi by 2018. So again, most people agree. If you go onto the internet, read various journals, you'll find that the vast number of people out there believe that there is going to be a very big shift, not only in terms of data usage from Wi-Fi, but also for voice over Wi-Fi offload. Here is one of the nicest examples I found recently of a high-density application for Wi-Fi offload. This is the AT&T Stadium in Dallas, and in 2010, the Super Bowl was played there, and during 2010, during the Super Bowl game, during about a 4.5 to 5 hour period, 75 gigabytes of traffic moved in and out of the stadium. But this has exploded. During 2015, during a regular game, the traffic has exploded now to greater than 5 terabytes per game. So we've moved from 75 gig in 2010, which was the Super Bowl, to over 5 terabytes during a regular game in 2015. By the end of the game, more than 30,000 devices will have been supported. Somewhere in the region of 35,000, 36,000 devices will have connected up to the Wi-Fi network. And at any instant in time, anywhere from 26 to 28,000 devices could be concurrently supported. Also, very interestingly, in terms of network stress, during the half-time period, the download and upload data can be equal. Most people always assume that download data is going to basically outstrip the upload data. But I suppose during the half-time period, everybody's been doing selfies, taking videos, so they're now posting them up to the internet, so a vast amount of traffic comes out of that stadium during the half-time period. By the way, this doesn't take into account the amount of traffic over the AT&T LTE network and other LTE 3G networks which users could be using. So in total, the total amount of traffic could well exceed somewhere around 6 to 6.5 terabytes during the course of that game. Now, who's using Wi-Fi calling? This is relatively new. We have already seen quite recently a very big announcement from Google with their Google Fi project, where they're allowing users with their Nexus 6 phone to make voice over Wi-Fi calling. And the first choice for Google will be to use Wi-Fi. They've actually contracted with T-Mobile and Sprint as backup services. So if Wi-Fi isn't available, then you'll fall back to the traditional LTE 3G environment for your voice calls. Other companies have already been providing this type of service, such as Republic and Scratch. They both have services which they have as their first choice Wi-Fi for connectivity and LTE 3G for backup. Both of these companies are providing a whole smorgasbord of different capabilities and service plans for the user, ranging from a pure Wi-Fi experience to a hybrid system which uses Wi-Fi, LTE, and 3G with a range of plans in between. These types of networks, by the way, which are going to use different technologies, are often referred to as heterogeneous networks, or simply HETNets for short. Comcast, as I said, deployed over 8 million hotspots last year. They also have a voice over Wi-Fi calling system. Sprint, just a few weeks ago, announced Wi-Fi calling as well. T-Mobile have been pushing very aggressively with Wi-Fi calling and claim that they have around 7 million hotspots in the US today, which their users can offload onto. AT&T and Verizon have been a little bit slower on the uptake, but we expect to see Wi-Fi calling from AT&T and Verizon, I would imagine, by the third or possibly at the latest fourth quarter of this year. So now, with no pun intended, I'd like to hand off to Rich.
So thank you, Alan. I'm going to take a few minutes to go through some of the lessons that we have learned in some of the early stage voice over Wi-Fi rollouts that we've been involved with globally. So it's real. Voice over Wi-Fi is in the early stages of rollout. As with all new IP services, user experience will be key to adoption. If users experience poor quality, failed handovers, dropped calls, it could set a hard-to-shake user perception that would be tough for the industry to overcome. So let's get it right the first time. As with VoLTE, Spirent's been involved in some early rollouts, and here are a few early lessons to pass on. First lesson is to measure what matters. As with previous generations of voice service, what really matters is what the user experiences. Voice over Wi-Fi reintroduces some things that the industry tackled long ago when it controlled the whole network. Things such as audio loss storing handover, handover parameters, and steadily improving in coverage to reach sort of a 98% plus call success rate. We shouldn't assume that years of engineering a solid voice experience will magically happen with a new voice service that in most cases flows partially over networks out of our control. Even with several years of Wi-Fi capable smartphones under our belt, we also experience mobility-related issues where your device will hang on to a fading Wi-Fi signal too long and stall out the web page you were browsing or the music you were streaming or some other file download. That kind of stall is going to feel even starker to a voice user. So like VoLTE, expectations are set in the user's mind. We need to meet and exceed those expectations. And to do that, we should focus on objective assessment of things like speech quality, audio loss, audio delay. The next lesson is to take a service-centric approach. So given the need to properly quantify the experience, we have to accept that this is not always possible from the network side. Service providers don't have network probes and instrumentation to systematically assess customer experience of voice over Wi-Fi, as they don't own the end-to-end. So while some insight can be derived from the network side, in the end, assessment from the device and the user side on commercial devices gives a more dependable picture of quality, gaps in audio, handover performance. Lesson number 3, you need to compare to the alternatives. So we all know that the competitive landscape is rapidly changing for the industry and for service providers especially. With the evolution to IP-based services, the playing field is leveled to a point. You now have many over-the-top service providers in the mix. So initial perceptions of voice over Wi-Fi and comparisons to previous experience and competitive service, it will influence the adoption rate and impact the ultimate goals of sort of a ubiquitous and uninterrupted service coverage. So with the pace of innovation and the introduction of this new competition, it's really important to get regular and quantified views of what you offer relative to both competition and to the earlier generation services that users are familiar with. Lesson number 4 is to get realistic and don't assume. that everything is just going to work itself out. Just because you don't own the last 30 feet, don't assume that you have to let the user experience chips fall where they may. Performance and experience in real-world scenarios can be assessed and inform your decisions on things like handover thresholds, routing, device requirements, etc. We recommend exercising the service and your devices in different IP loading conditions and in different controlled and uncontrolled scenarios that are part of your service rollout plan. This includes public hotspots, enterprise Wi-Fi for your key corporate customers, and hotspots that represent a typical home. In the end, the service that offers consistent quality across different access networks and in myriad real-world conditions wins. So those are the lessons. I'm now going to pass off to Rupert Lloyd, who will go through some early results that we found.
Thanks, Rich. Hello, everyone. I'm Rupert Lloyd. I'm going to share some of the test methods we've developed to measure voice over Wi-Fi experience. I'm also going to share some summary results from measurements we've made on commercial voice over Wi-Fi networks. When a new technology like voice over Wi-Fi starts rolling out, the key question on the mind of many service providers is, how do I know when it's ready to launch? And to get the answer to that question, you need to understand how a user will actually experience the service once it goes live. So you need to be able to measure all the key factors that directly impact experience in a reliable way. Two of the key elements for measuring voice over Wi-Fi experience are a voice over experience probe and an on-device diagnostic app. Both interface with a specific device under test. The voice experience probe needs the ability to control any off-the-shelf device, so you can evaluate experience using the same devices as your customers. That ensures your tests are highly realistic. Furthermore, the probe needs to be able to inject speech samples into the device and measure speech quality, audio delay, call drops and blocks, and setup times. Basically, all the key factors that influence the user experience. Because handoff to LTE is a key aspect of many voice over Wi-Fi service offerings, you also need the ability to determine when a device is using an LTE bearer or when it's using a Wi-Fi bearer. And that's where the diagnostic app comes in. It also provides other useful information about the RF status of the device to help isolate issues when you experience poor performance. Using the voice experience probe, test calls can be made over a live network using either LTE or Wi-Fi technology. In order to measure experience before, after, and during handoff, we use a programmable attenuator connected to the antenna of the Wi-Fi access point to ramp the Wi-Fi transmit power up and down and effectively trigger the handoff between a live LTE and the Wi-Fi network in a controlled way. The other key elements of the measurement system are a voice server that connects to the PSTN and a voice experience probe connecting to a reference or receive end device. And depending on the exact tests you perform, you'll typically be able to use the same physical voice experience probe at both ends of the end-to-end service link if you so desire. Basically, the voice server and receiving end voice experience probe allow you to terminate a voice over Wi-Fi call through multiple different networks. As we'll see in a minute, the terminating network connection can have a significant impact on the user's experience. This diagram represents the setup we'll use for all the measurement results, which I'm going to share over the next few slides. Before I dive into the results, I'd like to explain a little more about the configuration we use to measure experience before, during, and after handoffs between voice over Wi-Fi and VoLTE. The diagram you see depicts the scenario where a VoLTE call is initiated on an LTE dedicated bearer and then handed off to a voice over Wi-Fi bearer. A sample test would proceed like this. After the VoLTE call has been established, the signal attenuator is adjusted to increase the Wi-Fi transmit power. The received Wi-Fi at the DUT is measured by the onboard diagnostic tool, and this is shown as the dark line on the chart. The received Wi-Fi power is now sufficient to meet the policy for handoff to occur, and this is the transition point between the first orange section and the middle blue section. After sufficient measurements have been made during Wi-Fi access, the call is terminated. And the Wi-Fi signal is attenuated to the previous low level, and then the cycle is repeated. For handoffs from Wi-Fi access to VoLTE, the procedure is reversed. So now we'll move on to looking at some of the results of our measurements. One point I'd like to make before I do that is that many of the measurement results I'm going to share with you are from early stage devices. So while the results are what they are, please keep in mind that the technology moves very quickly in its early life cycle, and operators are also liable to make substantial optimizations during this phase. For these first set of results, we evaluated a commercially available voice over Wi-Fi enabled device on a live Wi-Fi and operational LTE network. We looked at both the uplink and downlink and VoLTE to voice over Wi-Fi and vice versa for handoff. The chart you see shows how speech quality prior to handoff averaged around a Polka score of 4. That's a very clear call. But during the few seconds before and after the handoff, the speech quality dropped precipitously to an average of about 2, which most users would say is a very annoying level of impairment. And this pattern was seen on both links and in both directions, both VoLTE to voice over Wi-Fi and vice versa. Although we've only shown results here for the downlink, the speech graph below the chart shows the actual speech pattern before, during, and after the handoff, and it gives the clue as to why the speech quality was so poor during handoff, which we'll get into on the next slide. Because we saw such a major drop in speech quality, we decided to investigate exactly what was causing this. Using Android system diagnostics and QXDM diagnostic logs, we were able to isolate the problem to dropped RTP speech packets during the handoff. We decided to quantify this impact on the audio by measuring the total amount of audio lost during the handoff. Essentially, we summed up the total amount of lost audio seconds from the first point of significant audio loss to the last point of significant audio loss. And we observed that there were often multiple sections of lost audio during the handoff procedure, interspersed with normal audio. Though in many cases there was only one period of significant audio loss. The charts to the right show the total audio loss during handoff for the uplink and downlink of VoLTE to voice over Wi-Fi handoffs and vice versa. We noticed that VoLTE to voice over Wi-Fi had a consistently higher total audio loss with respect to voice over Wi-Fi to VoLTE, especially on the uplink direction. Our next set of results come from measurements performed on multiple Wi-Fi access points across several businesses and residential locations. This particular case focused on evaluating call performance and speech quality and included over 1,500 voice-over Wi-Fi calls between 2 mobile devices. There were 2 scenarios considered. One where both mobile devices were using voice over Wi-Fi. Those are the green bars in these charts. The other where one mobile device was using voice over Wi-Fi and the other was using a 3G mobile circuit switch voice service. Those are the orange bars. The key trend that you can see across all the charts is that Wi-Fi connections perform better across all metrics relative to Wi-Fi to 3G mobile connections. For call completion success rate, Wi-Fi to Wi-Fi was more reliable against Wi-Fi to mobile by a margin of 5%. Call completion success is defined in this case as calls that successfully originated and terminated normally, so it covers call blocks and drops. For call setup time, Wi-Fi to Wi-Fi was faster than Wi-Fi to mobile connections by about 3.5 seconds. Wi-Fi connections also showed better average speech quality, an average polka MOS of 3.3 versus 2.5 for Wi-Fi to 3G. Our last set of results come from a set of voice over Wi-Fi calls performed under two scenarios. One where the Wi-Fi access point was unloaded. That was, there was no traffic on the wireless LAN other than the voice over Wi-Fi call itself. And the other scenario where the Wi-Fi access point was loaded up to 90% of its throughput capacity. As you can see, heavy loading on the wireless access point had a significant impact on voice over Wi-Fi experience, particularly when it came to reliability and setup time. The traffic load caused the call completion success rate to fall from 89% down to 54%. And for call setup time, the traffic load caused average setup times to more than double from 6.9 to 14.4 seconds. The traffic load reduced average speech quality from an average polka score of 2.9 to 2.6. And our experience is that users can detect speech quality differences of the order of around 0.3 MOS points. So this degradation would be subtle, but noticeable. So this concludes our slide presentation, and now we'll move on to take some questions.
All right. Thanks, Rupert. This is Kyle again. Yeah, we have quite a few questions come in during the webinar, so we'll just jump right in. So Rupert, the first one, let's start with you. Can you provide more details on how you determine the number of lost audio segments during the voice over Wi-Fi handoffs?
Yeah, sure. So we're looking at both audio that was lost by measuring the output speech from the device itself, the analog speech, so exactly what the user is listening to. But also we're looking at the network layer, at the RTP speech packets that are carrying the media, and using the sequence numbers and timestamps on those packets to kind of figure out what was missed during the handoff. So to capture the audio output from the device, we use our Nomad voice experience probe, which also does the the polka scoring, and we're able to get the full audio waveform and see exactly which section of speech is missing. To do the network analysis, we use QXDM, which gives a lot of diagnostic information from the baseband during the VoLTE call. But on this device, it did not give diagnostic about the Wi-Fi calling because that happened on the application processor of the Android device. So we used, in addition, a diagnostic running on Android to give us the network diagnostics on the Android half of the call, on the Wi-Fi half of the call, so we could compare those timestamps and sequence numbers and determine exactly how many speech packets were not received during the handoff.
All right, great, thanks. Alan, we had a couple questions come in for you. First one, what will be involved in upgrading the deployed Wave 1 to have the same capacity as Wave 2?
Okay, well, basically, you won't be able to upgrade, as far as I know, a Wave 1 access point to Wave 2 unless it had some form of modular radio, because the hardware is quite different. To go from Wave 1 only had 3 radios, 3 antennas supporting 3 spatial streams, and didn't support MU-MIMO. To go to Wave 2, you need 4 radios at least, and 4 antennas, and the software is quite different to support MU-MIMO. One other thing I'd like to touch on, by the way, because of the increased speed of the access points, something a lot of people have overlooked, is that if the access point is running greater than 1 gig, you need to get the data out. The Ethernet today deployed around the world is typically running at 1 gig, unless you're very fortunate you've got a 10 gig connection, but most are only running at 1 gig. So there is some new technology from the IEEE coming out. There are 2 competing groups which have been pushing the technology, the N-based T Alliance and the MG-based T Alliance, and you'll be able to upgrade your Ethernet capacity to 2.5 gig and 5 gig in the future. So watch out for that tech. It's just beginning to hit the market. Some companies like Cisco are already beginning to ship. And this is purely being driven by the fact the access points are going to run so quickly.
All right, great. Next question we had come in, Alan, is will EAP SIM work from multiple wireless carriers to a Wi-Fi network supplier, or will a business relationship be required?
Okay, well, EAP-SIM will work. In fact, the way the system should operate is that the access point will broadcast in its beacon or supply you with the information on the carriers that it's supporting. You'll then use typically EAP-SIM to authenticate and gain access to the Wi-Fi network. Basically, a VPN will be set up from the access point, which will backhaul you through the network to your carrier's trusted wireless access gateway, or TWAG. Some people just call them a WAG, or wireless access gateway. I prefer the TWAG because it's trusted. That, in effect, will then take you off pretty much to the AAA server, which will then do the authentication. So actually, one access point should be capable of supporting multiple carriers. However, just recently, I've read that there's going to be a new release of Passpoint Release 2 or version 2, and you'll actually be able to authenticate using social media logons. So you'll be able to use things like Facebook, LinkedIn, or your Google ID to actually gain access. I'm assuming once you've entered this information into your phone, it will stay there and it'll continue to authenticate automatically, because you really don't want to be bothered with this every time you hand off from LTE to Wi-Fi. But I think really the preferred way, in my opinion, this is just my opinion, will be to use the way that everybody's going today, and that's basically using EAP-SIM, or basically using the credentials straight off your SIM card.
All right, thanks, Alan. The next question we had come in is for Rich. So, Rich, can you talk a little more about the general trends and how Voice over Wi-Fi experience compares to Voice over LTE experience based on what you're seeing in early deployments?
Yeah, sure. Good question. So I think the top line response is that Voice over Wi-Fi has the ability to deliver comparable performance, especially with speech quality. There are, I think, some outstanding questions about audio loss that I think the industry will learn more about as more and more of these rollouts occur. I think the key thing to remember here is there are sort of coverage and loading dependencies, as with any wireless network that we have to deal with Voice over Wi-Fi, and those are going to affect the end user's experience, depending on again where they are, whether they're going to public hotspots, enterprise Wi-Fi. But the long and short of it is it can achieve a similar experience as VoLTE.
All right, thanks, Rich. Next question we had, and I'll open it up to all three. Is the device diagnostics app embedded or post-loaded? Someone is just wondering how the app gets on the actual device.
Oh, sure. This particular, well, the QSTM diagnostic is kind of built into the device, the baseband. The app that we used for our Android diagnostic was installed post. It was a post-installed app.
All right, great, thanks. And then also, what was the tool that was used on the Android headsets?
I guess that's kind of referring to the previous question. So it's a Spirent tool that's part of our Datum product, and it collects RF measurements and many other kind of diagnostic KPIs from the device.
All right, thanks. We also had a number of questions in reference to E911. So the first one, in a stadium-like environment, if 2 or more companies are providing Wi-Fi services as well as voice over LTE, who will have responsibility to E911 call completion to the PSAP?
Yeah, this is Rich. Alan, please pipe in. So I can't give a definitive answer to this. We can probably circle back with the questioner, but I mean, there's a couple of things to point out here. I mean, one, the regulations and expectations around indoor E911 are sort of just now being sort of worked out and discussed between regulators and service providers. I don't believe there's been any sort of firm decisions about who has to do what, but I know the industry is being very proactive around this, setting up test beds and other things. Another thing to point out is that E911 in sort of this era of IP based voice is going to rely on hybrid solutions. It isn't just going to be wave arrival math or satellite-based answers. It's going to rely on Wi-Fi access points, low-energy Bluetooth. It's going to be a whole set of technologies that contribute to this. So I think there's some runway here to that the industry's got to go down to to come to a point where there's agreement about how E911 is going to occur over voice over Wi-Fi, and it's going to have to develop over time.
All right. Alan, did you have any comment on E911 and how that works on the system?
Oh, yeah, sure. One of the important things is actually to pinpoint where the person's calling from. And this technology is moving along very nicely within the Wi-Fi area. And today, I was just looking at a demo yesterday, actually, with some Hewlett-Packard equipment. They can pinpoint your location within approximately 1 to 2 meters, even if you're indoors using Wi-Fi. There are a couple of reasons for this. It's not just for emergency services. There's also another commercial reason. What they want to do is like I don't know if anybody saw the movie The Minority Report, but they want to target advertising towards their users. So if you're within range of a major department store, within a meter or 2, then what they'll do is they'll push an ad to your phone. I'm assuming long as you subscribe and agree to receive those types of ads. So there are many different reasons to have good location-based services on the device and in the network. So number 1 for 911 emergency calls. Number 2 for commercial reasons, so they can basically push ads to you. And number 3, just to find your way around the shopping mall. That could be very useful as well, or within a large airport. Some airports have already deployed services so that you can find your way to the gate using an app which you can download in the airport. Spirent has been on the forefront of this technology, And one of our divisions has actually got test equipment so that we can simulate an environment where we can basically simulate a phone moving around a particular landscape, and we can test that the positioning software is working correctly. So this is something actually Spirent, I think, is quite on top of, actually.
All right, great, thanks. Next question we had in, could there be a little more elaboration on how traffic loading was introduced for the Wi-Fi access points over commercial networks?
Yeah, I might need to get back to you on that question because the engineer that carried out that test isn't in the room here. But I believe they set up basically simulated traffic like down by HTTP kind of downloads to test servers to load up the network with traffic to almost to the capacity.
Yeah, actually, Spirent's got a lot of equipment which can actually load up networks. For example, we've got a product called the Landslide, and that's focused on generating traffic and emulating environments for LTE 3G types of networks. And I couldn't go into all of the details this morning, but basically we can emulate tens and tens of thousands of UEs and thousands of access points, creating a situation where users are roaming from one access point to another. Simultaneously, those users can be generating and receiving a lot of traffic off simulated servers. So depending on the testing required, we can scale up to literally hundreds of thousands of users, or do a test which is basically purely for functional reasons. So we could scale down the other way and just do a functional test.
All right, great, thanks. Next question we had come in, is there any solution for non-VoLTE operators for voice over Wi-Fi to legacy 3G networks call continuity?
Well, I think the short answer to that is yes, and we've already seen operators in Europe either rolling that out or exploring it. Given that they are not quite as the U.S. is a little bit ahead there, the carriers here. So some of the VoLTE rollouts in Europe are sort of happening sort of over the coming year, but they still want to sort of achieve the advantages of using voice over Wi-Fi by coupling it with their legacy networks. So the short answer is yes.
Yeah, there was actually a company, you may have heard of them, called EE. They used to be called Everything Everywhere. Just a couple of months ago, they launched their Wi-Fi calling service, voice over Wi-Fi, in the UK. This was a major breakthrough because for the first time now you can actually make phone calls on the London Underground because there's Wi-Fi coverage down there. I think, in fact, British Telecom are going to be purchasing EE for a few £billions sometime during the course of the next 12 months. That's already been announced publicly. So there is a lot of movement going on in Europe, and I think EE, which is a pretty much cutting-edge company in terms of deploying new technology, they're already pushing this type of application.
Thanks. And we received another question which can kind of work as a follow-up. How many devices are currently supporting Wi-Fi calling?
Okay, that's a good question. There are not that many, actually. I indicated in my slide presentation some of the devices which are covering Wi-Fi calling. The new generation of iPhones, in fact, if you go to the iPhone website, I was very surprised because it actually explains in a lot of detail how to configure your iPhone for voice over Wi-Fi calling, down to even getting into the IEEE specs. It even calls out 802.11u. I don't think for the regular user, such as my wife possibly, she's particularly interested in whether it uses, IEEE or 802.11u standards. So anyway, basically the iPhone, absolutely. The new generation of Galaxy phones, I think at least from the S5 onwards. And there are a number of phones continually hitting the market now. All the newer phones hitting the market will support what we call Passport or Hotspot 2.0. So it's definitely limited to the newer phones.
All right, thanks. And looks like we have time for just a couple more questions. The first one, what type of testing should be carried out on a voice over Wi-Fi network?
Okay, well, there's obviously 101 tests you could run, but in my opinion, I would do a voice quality assessment using Polka. Polka is what the perceived observable listening quality assessment, I think. I always get a little bit confused with these new acronyms, but Polka is very good because it actually tests wideband codecs. So it's going to test the newer codecs which will be deployed in these networks, which is basically going to give us a high-def voice. I think another good test would be the ability to roam between access points, you know, how well we can roam between LTE to LTE, LTE to Wi-Fi, Wi-Fi to Wi-Fi, make sure the voice quality is maintained, which I think the rest of the team covered very well earlier on. Verify that authentication methods work correctly as well, regardless of the type of authentication you're using, whether it's eSIM or if you're going to use social media such as Facebook, Google, or LinkedIn. Also, find out what the capacity is, how many authentications, you know, literally per second you can handle. If you're dealing with a very large sporting event, you may have thousands of people coming into the stadium, and all those phones will need to, you know, hand off potentially to the Wi-Fi network in a very quick fashion. And then, of course, capacity testing in parallel with voice quality testing. You know, how many users can we support? How many users can we support if they're all making voice over Wi-Fi calls? And also, just as importantly, what happens to the voice quality in the presence of a lot of data? We should be mapping good QoS, prioritizing the voice calls over the Wi-Fi network. And those are just some of the tests which quickly spring to mind. I'm sure there are dozens of other tests you could run as well.
All right,
yeah,
thanks.
Maybe just to piggyback on what Alan has described. I mean, with sort of the introduction of sort of these new IP-based services over devices that are now carrying multiple radios, sort of jammed into smaller spaces, you know, the list of tests that can be run, you know, it sort of goes exponential on you. You know, there's always a set of sort of conformance to standards tests or just basic functional tests. In the end, whether it's a new device or a new service, you know, we've got to accept that there's really no way to cover everything, but you can sort of minimize your risk and sort of have sort of greater confidence in launch by really measuring from the top down and measuring what the end user is going to experience on live networks in the lab to complement that assessment and on actual commercial devices. Because you know, you could run sort of conformance and functional tests till you're blue in the face, but if you're not measuring what the user is experiencing, you're really not going to know whether you know, what you want to happen is going to happen.
All right, thanks. That's about all the time we have today on today's webinar, assuring the successful launch of voice over Wi-Fi devices and services, presented by Spirent. Again, our presenters today from Spirent Communications were Alan Way, Senior Manager, Methodology and Platforms, Rich McNally, Director, Service Experience Programs, and Rupert Lloyd, Senior Product Manager, Service Experience Solutions. Thank you, everyone.